Hello, welcome back. This is my first video in this design series. Using this short video, let's discuss few of the real-world elements of the NSX-T design. This is Muhammad Marakutatil. Without further ado, let's start. So, as always, I am a real-world guy. I believe in correlating the information, correlating the solutions with the real world applications. It is very interesting that we have two different realms, two different world when it comes to networking in current times. The first one is physical realm or the physical world, and the second one is virtual. It is apparent that, and it is very clear, the dominance of the bare metal based offerings are no more. It is not working anymore. But as a networking and security architect, you cannot avoid physical networking. And for sure, you should know the bits and pieces of physical networking. Otherwise, I don't think you'll be able to succeed in this business. And don't forget, NSX is a software only solution. And without physical infrastructure, you cannot do the networking, you cannot interconnect the servers. This is the topology I want to reference for the discussion. Let's understand the idea a little more. In physical world, you usually have ADCs, physical routers, physical switches, security devices, proxies, all of those functions. And these all functions are handled by dedicated devices in your physical world. If you look at the second part, which is the virtual realm, all these functions are offloaded to the general purpose x86 boxes. Now let me take a step back and see what exactly the modern applications and modern networking is asking. With modern networking, the goal is to do very minimal changes to your physical infrastructure. Physical infrastructure by nature, it is not agile, it is not flexible. You cannot make changes very quickly and easily. Because of that, when it comes to physical infrastructure, we should perceive it is a very static and stable, and there is no complexity at all when it comes to fabric or physical infrastructure side. And all your agile networking and security requirements should be served by your software defined solution in your virtual realm, that is NSX-T. Now looking at this topology, you may get an idea whether it is an IPS device or load balancer or firewall or even an analytics apps. Essentially what is happening is we are taking all these elements and we are keeping these very close to the workloads where the computation is happening. For instance, in this diagram you could see there is a multi-layer switching icon, and you will see more when we move forward. So this multi-layer switching icon is there in each of those hypervisor host, which is used for doing all those switching and routing function for those virtual infrastructure, which is effectively the virtual machines. And when you have all these functions, what do you think will happen? Whenever these workloads need to have any security and networking functions, it makes use of the virtual infrastructure itself. It will never go to the physical world. And if we do so, we are essentially eliminating rack full of these discrete systems and devices. And literally you could see from my diagram, we don't have much when it comes to physical infrastructure. We just have one pair of physical switch form factor, which is doing the aggregation or borderly functions, and you have your edge routers connecting to the WAN. All your L2 to L7 functions required for your virtualized world are handled from the server itself. So with this, let's delve little more into the topology. So as you understand, the first part of the diagram is the physical realm. There you could find mostly the physical routers, switches, all of those. This is obviously to provide physical connectivity to the WAN and also to the server infrastructure. Right. Now let me talk about the third point, my third design point, and this is the virtual realm. This is dominated by the virtual realm, which is basically the second part of the diagram, where you have server infrastructure laid out across and mostly dominated by the hypervisors. When it comes to NSX-T terms, it is called transport nodes. The hypervisor could be an ESXi host, or it could be a variety of KVM flavors hosts such as Red Hat, Ubuntu, SUSE, CentOS, etc. And if you look at this number threes, these are the server host with ESXi or KVM. The green ones are the workload clusters, and the maroon ones are the edge clusters. And when it comes to edge clusters, this is where you will host all your edge functions. And for the workload, you have separate workload cluster that will host all your VM infrastructure. And just to highlight, creating separate cluster for workload and management or edge function, it is purely a design choice. Technically, you can club your workload cluster with edge functions. Yes, of course you can do that. But ideally, you should go with a separate cluster for workloads and separate one for hosting infrastructure elements such as vCenter, NSX-T manager, and all other edge functions. This is exactly you could find in my topology. Now let's also think through the VM density aspects. Let's say you have 32 or 20 to 30 VMs on a host. Of course, the VM density depends on the scale and capacity of the servers. And also to highlight, when it comes to performance, certainly you need to consider the resource requirement for doing networking and security function with NSX-T, like DPDK functions, doing Geneve offload, and the sizing of the edge functions required in your environment, etc. Now let's focus back to the diagram. There is a multi-layer switching icon which I represented part of each of the transport node. When it comes to NSX-T, it is called T1 and T0 distributed logical segments and gateway functions. Using these T0, T1 functions, your switching and routing functions are localized to the host itself. So you could see in each host you have this distributed capability where you don't need to go out of your host if you want to do any kind of routing and switching between the subnet, within the subnet, whatever it is. And this is the key benefit of the whole solution, right? You just think about it, most of them are already virtualized, their infrastructure 60 to 70 I would say, and there are customers already done 95%, 98% virtualization in their environment. So think about all this virtualized infrastructure. If they want to talk to each other, it uses the capability of the host itself to do all these routing and switching functions. This is huge. And if you really think through it, if you do this part, this is where I am stressing on. You don't require very hi-fi feature set on your upstream physical world. Moving on, my design point 4. In this, you could see each of the VM can have a stateful firewall attached to its NIC. So here, whenever VM need to talk, the security enforcement is done at the NIC level itself. And this is huge, right? So with this, we are doing micro-segmentation feature set right on to the VM itself. We are keeping those security capability very close to the workload. Now, with NSX-T you can get an option where to apply the rules you want to apply to a specific host or specific set of VMs or a specific set of network element, right? So you can pick and choose where exactly you want to deploy your security rules based on your requirement. Now with this, let's talk about my fifth design point. If you understand, I was talking more about the functions which is part of your host itself, right? Now, what if the VM in host want to talk to another VM in another host? So this is where it can make use of something called TEP, which is a tunnel endpoint, or in NSX-T terms, it is Geneve encapsulation. So let's understand what is the function of TEP. The TEPs are really there to carry the VM traffic from an host to another host. And there are lots of other discussion there, like replication mechanism, how does it send the traffic to all the destination VMs, how the replication works, what is hidden replications, right? For sure, we will talk about this in my later session. With this, let's move on to my sixth design point. In this, we are specifically discussing the edge clustering, where all the edge services like edge routing, edge firewalling, also known as north-south firewalling, load balancing, VPN, NAT, service insertion, physical to virtual gateway functions, DHCP, all of these things are done on your edge clusters, right? So this should be a high performing set of cluster you should have in your environment. And this is one of the reason, if you look at from the design perspective, we are creating a separate edge cluster, right? Especially due to the fact that when you want to do some kind of troubleshooting, traffic optimizations, resource optimization, this really helps. And of course, you always have some customers always want to do physical firewalling, physical load balancing. So in that case, you can certainly use edge cluster mainly for forming routing adjacency to the physical infrastructure or to your upstream routing element, whatever you want to call. And this is where BGP protocol, ECMP, all that fun stuff comes into play. So the idea is to get you the connectivity to the outside from your virtual realm here. So just to summarize, you have two different type of clustering. One is the workload cluster and the second one is the edge cluster. Edge cluster main purpose is to connect your virtual world to an outside world, right? And you also have all these L4, L7 services part of your edge cluster, where your workload clusters are mainly hosting your applications, and whenever the application want to talk to each other, it is taken care at the workload cluster level itself. And when the user want to reach your data center, your applications, it always comes through the edge cluster, right? And from there the traffic can go to your workload cluster for application access. Finally, I want to conclude this session with my design point 7. Here I want to touch upon the active or active standby options with the routing functions and L4, L7 services. So here these edge functions can be active on one of the edge node and standby on the second one, especially when it comes to edge firewalling, load balancer, NAT functions. You will have this active on one of the edge node and standby on the second one. But with routing, you can have active across your edge node with ECMP, right? So this is all I want to cover for now. We will definitely catch up soon in another video. Thank you so much for listening and happy learning.